For this topic, we are going to discuss the atomic emission spectrum and the quantum mechanical model. But before we can get into any of that, we're going to get through light. Be able to define amplitude, wavelength, frequency, hertz, electromagnetic radiation, or EM radiation, spectrum, and calculate wavelength and frequency. Be able to describe the effects of different frequencies of EM radiation on matter. That's going to be a little more later, but we are going to discuss microwaves in this one. And define the electromagnetic spectrum in terms of temperature, light, and the effects those are going to have on pure substances. So what is light? Well, light is a wavelength, and it has a frequency, and you can measure it in photons. You can see this at C. You may be familiar with E equals mc squared. C there is the speed of light. And here we have a new equation, lambda times v equals c. Lambda means wavelength, and it is measured in meters. So the wavelength is going to be the distance between the crests here. So when you have two crests of light, you're going to have between those a certain distance in meters that we're measuring. That is the wavelength. And frequency, here as v, is taken by cycles per second. So that's how many of those waves are going to pass in a given amount of time. And you can think, well, if the distance is longer, then the frequency will be lower. And yes, that means as wavelength goes up, frequency goes down. And as frequency goes up, wavelength goes down, which is why when you multiply these two numbers by each other, they always end up at c, the speed of light. C is equal to 2.998 times 10 to the 6 meters per second. So that's about 2.998 million meters per second. Frequency is measured in a unit called hertz, which is 1 per second. So how many wavelengths are passing through per second? Wavelength, as I mentioned beforehand, is measured in meters. So you have wavelength is meters times frequency, 1 over seconds, is going to end up with speed, meters per second. And what do you know? The speed of light is measured in speed. So we can use this to calculate things given an unknown. So if we want to find the wavelength of light that has a frequency of 5.09 times 10 to the 14th hertz, we're going to multiply lambda times that value right there, 5.09 times 10 to the 14th, and that will give us C, 2.998 times 10 to the 6th. So if you divide 2.998 times 10 to the 6th by 5.09 times 10 to the 14th, you will get 5.89 times 10 to the negative 7th for your wavelength. And that will tell you where your wavelength is. So we can just use this to figure out an unknown wavelength, and likewise we can figure out an unknown frequency. When you look at the electromagnetic spectrum, you can see that there are a whole bunch of different things that we would consider light. Gamma rays, like you may have seen in the Hulk, X-rays, like you may have seen at your doctor, ultraviolet rays, which you may have seen on vacation, and then visible light. The wavelength is different in these. Wavelength of the gamma rays is the shortest. It's 10 to the negative 14th. Wavelength of visible light is around 10 to the negative 7th. Then you have infrared, which is going to be longer wavelengths, and radar, then FM, TV, shortwave, and AM, longer and longer wavelengths with lower and lower frequencies. That's the electromagnetic spectrum. Wavelengths can be separated by something called a prism. So the prism is going to be able to allow wavelengths to be separated by their length. So what type of light here has the longest wavelength? That's right, red. What has the highest frequency? Well, that's right, purple.